Section 9.4 is equations of ellipses. An ellipse is an oval shape, and this oval shape comes from foci, or those focuses. So you've got an elliptical shape, an oval shape, and these foci are in here inside, and those come from, kind of like they did with the parabola, these two are equal distance from every point on the ellipse, and that's where those come from. So for today, that's not going to be as important. We are going to need to find them, and it'll become more important in a different lesson. So for right now, you just need to know that they're in there. All right. The equation for an ellipse is x squared over a squared plus y squared over b squared equals 1. So the trick with these equations is to get it equal to 1, and then you're going to have x squared and y squared amounts with squares underneath. If it's not a perfect square, then you can have a perfect, you can take the square root to get what a and b are. Now, if you'll look, an ellipse obviously can be horizontal or vertical, and so you need to know that if it's vertical, whichever way the long way is, that's going to be that's going to be where the foci are located. They're going to be on that axis, and so we call that the major axis. So if it's up and down, then the foci are going to be if it's a vertical ellipse, then the foci are going to be along the vertical axis. Whereas if it's horizontal, then the foci are going to be on the horizontal axis. Now in your book, they switched the A and the B, and that all got confusing to me. So here's the bottom line. Whichever is larger, the number under your X or the number under your Y, whichever of those two numbers is larger, that's going to indicate if it's longer horizontally or vertically. All right. So if the X term, these two terms indicate the vertices where the ellipse crosses this axis. So the A is going to be these terms, this far away from the center, or in this case, the origin. The ones we're going to deal with today are all going to start at the origin. And so the vertices are going to be the longer ones. The co-vertices, the co-vertex, are going to be the shorter ones, because the x-axis and the y-axis are both going to cross through here because the center is at the origin here. So the a squared is going to be, in this case, the x. Here's the a squared. This is a away from 0, and this is a away from 0. So these are co-vertices. And the b then is going to be longer. So whichever one is longer, that indicates whether it's if the b is longer than the a, then your ellipse is going to be vertical. But if your a is longer, if the number under your x is longer, then that means that it's going to be horizontal. Okay? So all of that confusion, let's look at one of them, and then you'll see, oh, this makes a lot more sense. So what we're going to do is we're going to graph and find the foci of 25x squared plus 4y squared equals 100. So here's the trick. You need this to be equal to 1. So all you're going to do is you're going to take that, sorry, I can't write and talk at the same time apparently. You're going to take this equation, and you want the right-hand side of the equation to be equal to 1. So just divide it by whatever that number is, and then it will become 1. Now, obviously, if you have to do that, if you want to do that, you can, as long as you divide everything by the same thing. So divide every part by 100 in this case. So now when we reduce this down, this becomes x squared over 4 plus y squared over 25 equals 1. So now if you'll look, this 4 is 2 squared, and this 25 is 5 squared. So now we know that the 5 is longer than the 2, so our y-axis is going to be longer. So therefore, it's going to be elongated up and down. It's going to be a vertical ellipse. So this is where our ellipse crosses. In this case, because the middle is at the center, this is where this crosses the axes. So the x value crosses at 2. So along the x-axis, you're going to 2 to the right and 2 to the left. And there's our 2 vertices. So there are co-vertices. The co-vertex, remember, are the shorter ones. And for the y value, you're going to go up and down 5. 1, 2, 3, 4, 5. There's 1, 1, 2, 3, 4, 5. There's our other vertex. And so, oh, here we go, drawing. You can do it more beautiful than I. Oh, looky there. Oh, don't talk yet. There we go. Yeah, not too bad. All right. And there's your graph. Ta-da! Easy sneezy. So if it were to have been switched and the 5 were under the x, then the 5 term would go left and right, and then our ellipse would be horizontal. Now, to find the foci, and for right now we need to find them so we know where they are, and also because later on we're going to use them to find an equation. The foci is, C is the distance that the focus is from the center. So C is center. C equals a squared minus b squared. Now what I'm doing there is whichever one is bigger minus whatever's smaller, because we need that to be a positive number. So we've got 5 squared minus 2 squared is going to equal C. And I did the square root of it because C squared equals this. So do you see why I did that? I did that in one step. So C squared equals 5 squared minus 2 squared, and so the square root of that equals just C. So C equals 5 squared is 25, minus 4 is 21, so C equals the square root of 21. So this is going to be the positive or negative square root of 21. What's the square root of 21? You know what? I don't even know, honestly. And I didn't do that one. Let's see. 4 times 4 is 16. 5 times 5 is 25. So it's somewhere between 4 and 5. So we're going to put it right there. Square root of 21 negative. And the other focus is going to be square root of 21. So there's where our foci are. All right. So find it and circle it. There we go. And circle it. I like you to circle your answers so I know what the answer is. Okay. Now, so can you graph them? Hopefully that's not too hard. Go back and look at it again if it's where? They're quite simple. When we're in the center, they're really easy. Now I want you to write an equation with a vertex of 0, negative 7 and a covertex of 4, 0 with the center at 0, 0. So it might help you to look to see, okay, if the vertex is 0, negative 7, that's going to be down here, and the covertex is at 4, 0. So this looks to me like it's going to be along the up and down way, vertical. So what we're going to do is we're going to have x squared over something plus y squared over something is going to equal 1. We've got to figure out where our vertices are. How far away are we from the vertex? So for the x distance we found out was 4. So this is just going to be 4 squared. The y distance is 7, so this is going to be 7 squared. So your final answer is x squared over 16 plus y squared over 49 equals 1. Simple. All right, so if they give you a vertex and a covertex, finding the equation from that, if the center is at 0, is really, really, really simple. All right, just square them and make sure you match them up, the x with the x value with the x, and the y value with the y. Okay, so next we're going to make it a little bit more difficult. You need to write an equation with a vertex of 10, 0. So we've got the vertex is 10, 0, and the focus is 8, 0, which means if the focus is on the same the same axis, that means it's going to be along the horizontal way. So it's going to be, I don't know what it is, but generally it's going to be skinnier on the y is going to be smaller. But we need to know what that is. And if you'll remember, to find the focus, c squared equals a squared minus b squared. C squared equals a squared minus b squared. And we need that. We need the b because we have x squared over, this is our x, so 10 squared plus y squared over, we need the b, and that is just going to equal 1. So we just have to find out what that is. And in this case, we know what the focus is. We know the focus is 8. So 8 squared is 64 equals a squared, which is 10. So 10 squared is 100 minus b squared. Did you see where I got those numbers? The c is the number that you get from the focus. And then the a squared is the number that you get from your vertex. All right. So from the 0 is, we're not going to get off of that axis. So the number that is different from the 0 is the one that matters in this case. When we've got the center, it makes it much simpler. So now we just solve for b, and that's what's going to go in our unknown here for b. So what I would do is add the b squared to make it positive and subtract the 64. So b squared equals 36. And what we want is b squared. So let's just leave it squared. So leave it 36. And we want the 10 squared. So let's just make it 10 squared is 100. And then you're done. That's your equation. These really are this simple, I promise. Okay, so you know that I have to make it a little bit more difficult. I've got to give you a word problem because otherwise this was just too simple. So in this word problem, and even the word problem is fairly simple. So I've got a lightning, I didn't know this, but according to your book, lightning strikes tend to be an elliptical shape. And so what they're saying is, we've got this elliptical shape that is 400 meters long and 200 meters wide. And what they want to know is, well, what is the equation for this elliptical shape? And then what is the area that encompasses this particular lightning strike? So what we need to do is this. To find the equation we know is x squared over a squared plus y squared over b squared equals 1. That's easy. So the x, now in this case, the x is going to be the east-west direction here. And now remember that if the center is in the middle, that's good, isn't it? If the origin is here, then the distance from the center to the edge of the ellipse is that amount of this a. Okay? So it's not the full 400. This is just going to be half of that. If the 400 is all the way across this ellipse, then from the center out is only half of this. So this a squared is going to be 200 squared. And then the b is going to be half of the 200 because it's 200 all the way across the ellipse, or all the way up and down. All the way across the ellipse is 200. So halfway across the ellipse is 100. All right. So then your final equation would either be just this, or x squared over 20,000 plus y squared over 10,000, and that equals 1. That's your equation. Now, to find the area of an ellipse, I gave you an equation here. So the area equals pi times a times b. So the area is going to be pi times a, and now remember a isn't this value, a is the value before you squared it. So pi times 200 times b, which is 100. And so 200 times 100 is 20,000 times pi. And if you put in pi into your handy dandy little calculator, 20,000 times pi. The area is roughly equal to 62,800 meters squared. So if you are in that area when that lightning strikes, you're in bad shape. All right, so I think these are fairly simple. The trick is simply going to be to make sure that you're squaring when you're supposed to square and square roots when you're supposed to square root. The only really tricky part, I think, is the focus, finding that focus. Now, why did I need that and where did that come from? All right, if you've got questions, be sure to ask me. I'll see you next time.